right, so we're going to talk about pattern block fractions, and we're going to talk about what they represent. So if this is going to equal our 1 whole, so that's going to be this piece, then what is this piece plus this piece? Well, this is going to be this one. So how many of these does it take to represent one of these? And that is 2. So if I just have one of those, that would be 1 over 2. So then we have a triangle. Well, how many triangles does it take to cover this whole piece? How many do you think? So it's actually going to be 6. Oops. Take 6 of those pieces to make a whole. Well, I can get them all on here. So take 6 of those pieces to make a whole. So if I have one of those pieces, how much is this one worth? 1/6. So now we can add them together. If I have 1/2 plus 1/6, I need both of their denominators to be the same. So I can change my half to a 6. And how many 6s? So if I have a half, how many 6s does it take to make a half? That would be 3. So now that becomes 3 6s plus 1/6, which gives us 4/6. And then, of course, you can simplify by dividing it by 2 to give us 2/3. Okay, so now if we have 2 of these, if these both together equal a whole, that means that this one piece is a half. So now, instead of this being a half, how many red pieces will it take to cover the whole thing? It's going to take 4. So it's going to be 1/4. Well, if this takes 6 to cover one whole, how many is it going to be to cover both wholes? 1/12. So now we have 1/4 plus 1/12. Well, again, we're going to change our fourths to be twelfths. And how many twelfths are there in this 1/4? 1, 2, 3. So that becomes 3/12 plus 1/12, which gives us 4/12. We can simplify by dividing by 2 to give us 2 6s. We can divide by 2 again to give us 1/3. Okay. So now let's look at the next one. So this is a whole. So if this is a whole, and I have this piece, well, how many of these does it take? 1, 2, 3. So if I have a 1 yellow and a blue, that would be 1 1/3. So what about a yellow and a red? What do you think that would be? Well, this is half of that, so this would be 1 1/2. So now we have 1 1/3 plus 1 1/2. Well, if you look, I can't change my half into thirds. Can't do it. But I could change my half into 6s again, and that would give me 3 6s. So now that can become 1 3 6s plus how many on here? That would be 2 6s. So 1 2 6s, which would give us 2 5 6s. Well, there we go. So now we have 2 of these equal a whole. So if we look here, when I doubled this got doubled here, and this got doubled here. Sorry for the...
Meet with Ms. Beecham in her classroom for the committee. Thank you.
All right, sorry about that. So this doubled and this doubled. So what do you think is going to happen here when we come down? Almost the same, but not quite, because this is going to represent a whole each time, but this means 2 has to be a whole. So this is going to be a half and a third, and this is going to be a half and a half. Right? Nope, because this is only a third of one piece, so it's actually going to be a sixth, because out of both pieces, it's going to take 6 of them. It's going to take 3 here and 3 here. So see, it's no longer a third, now it's a sixth. So if this is no longer a half, because I have a hole here, this is a hole. How many pieces of the red does it take? A fourth. So now I can add them together. So I can do 1/2 plus 1/2, I know is going to give me a whole, plus 1/6 plus 1/4. So again, let's take our fourth and see how many, these are going to be twelfths this time, because remember when we have 2, it became a 12th. And there's 3 of them. So that becomes 3/12. And then we have our 6th, and it takes 2 of those. So that's 2/12, which gives me 1 5/12. All right. Okay, and we're going to skip those 2 for now. All right, we're going to flip over to the back. So Dan and Brian are baking a cake for their mom's birthday. The recipe calls for 3 3/4 cups of flour. Dan has measured 1 1/3 cups of flour. Brian has measured 1 1/2 cups of flour. How much more flour do the boys need in order to bake their mom a cake? So we're going to figure out how much they did first. So if I have 1 1/3 plus 1 1/2, we're going to switch these. So we have the common denominator, and I can change them both to 6s. So if I go 2, 4, 6, and I can go 3, 6, and you see we have 6s. So to get here, I timesed it by 3. So here I'll times it by 3 and get 3 6s. Here I timesed it by 2. So here I times it by 2 to get 2 6s. So 2 6 plus 3 6 is 5 6. 1 plus 1 is 2. But we need 3 3/4. So now I'm going to do 3 3/4 minus 2 5 6. Again, we need common denominators. So let's do a power towers. We have 4, 8, 12, and then we have 6 and 12. They have 12 in common, so let's make them both 12ths. I got here by timesing by 2, 1, 2. So here I need to times by 2 to get 10. 1, 2, 3 times by 3 to get 12. 3 times 3 is 9. 9 minus 10. Uh-oh, we can't do it. So I'm going to rewrite it down here just so I have nice, pretty numbers. And we're subtracting. I need to borrow. So this becomes a 2, and I'm adding on a whole. And our whole needs to have 12ths. So how many 12ths make a whole? 12 12ths. So 9 plus 12 is going to be 21 12ths. Now I can subtract 21 minus 10 would be 11 12ths. 2 minus 2 is 0, so they need 11 12ths left. If you need to re-watch this part, rewind it and do it again. All right.